Hi, we start a session on some applications of Heron's formula. Previously, we learned the findings or the formula of Heron's formula. Let's now get into some applications. I will write the first question here. It says, find the area of the given quadrilateral. I'll draw the figure ABCD. The sides are given actually. I'll draw it, where the angle between the first two sides is a right angle. Let me draw the figure here somewhere. It says AB. This angle, which is between AB, is a right angle triangle. Right, it's a right angle. Sorry. This is the figure. It's A, B, C, and D. This angle, it means, is 90 degrees. It is also divided like this. The information given about the sides, this is given to be 9 meters, this is 40 meters, this is 28 meters, and the last one, this is 15 meters. We have to find the area of these this four-sided figure. This has been now divided into two triangles. Now if you see ABC is a right triangle triangle, we can apply Pythagorean theorem to find the hypotenuse, which is AC. So in triangle, in that case, we can divide the whole quadrilateral into two triangles and find their area separately. So in triangle ABC, AC square is equal to AB square plus BC square, or I can directly write AC is equal to root over of AB square plus BC square. That's giving me 81 is 9 square. BC is 40, that is 1600, so it is 1681 square root I get as 41 meters. So this is 41 meters. We can find the area of triangle ABC by simply applying half base altitude. It is also a right angle triangle. So, area of triangle ABC is half base altitude. So I'm getting 29, it's 180 meters square. We now need to find area of this triangle ACD, and then we add it to the area ABC to get the whole area ABCD. Look at the triangle ACD. We'll be applying Heron's formula to find this out. We don't have the hypotenuse, so we don't have the altitude, so we'll be applying Heron's formula. To do so, it will be S minus A, S minus B, and S minus C. So here, let me calculate S, because S is A plus B plus C by 2. So I'm getting 41 plus 28 plus 15 by 2. That's giving me 40 60 by 18, 42. Now this is S. We will apply it here in the formula. So it would look like 42. One side is 41. The other side is 28. And the third side is 15. So I get this as 42 into 1 into this is 14, and this gives me 27. If I find the square root of all this, I get 126 meters square. So the whole area of ABCD will then be area of ABC plus area of ACD. That's, I think, is giving me 306 meters square. This was not that difficult. Let us move on to another question. I simply would write down the question. It says, find the area of a trapezium whose parallel sides 25 meter, 13 meter, and other sides are 15 centimeter and 15 centimeter. Okay, the non-parallel sides are equal, that means. So I draw a trapezium first. Wherein these two sides, they say, are equal, and this is 15 centimeter. Here also it will be 15 centimeter. I will have to name them though. A, this is B, that is C, this becomes D, whose parallel sides are 25 and 13. So obviously this will be 13 and this will be 25. That's the figure. We have to find the area. Now how do I directly find, because we don't have altitudes, obviously we'll be applying Heron's formula somewhere and divide this trapezium as a parallelogram and a triangle. To do so, I draw a line parallel to AD and make this, suppose, as E. Now ADCE becomes a parallelogram. Even in that case we don't have altitude, so okay. So what will be AE? AE will be 13, so thereby making, okay, I'll write this using different color. This is now becoming 13, and obviously the rest of it will then be, that means EB, it becomes 12 centimeter, right? In this triangle BCE, so I'm finding out BCE. I don't have this third side area. Yeah, this is 15 centimeters. Okay, let us apply Heron's to find BCE area. I'll write area of triangle BCE. I'm not writing the whole of S. We can directly calculate S. S will be 15 plus 12 plus 15, that is 30, 42 by 2. So that's giving me 21 centimeters. So area will be 21, and then 21 minus 15, 21 minus 15, and then 21 minus 12. So this is 21, 6, this is 9, 3, this is 6 and 3, 18, root 21 centimeters square. This is the area of the triangle BCE. Now we also need to know the altitude because we have to find the area of the parallelogram, right? How do we find area of the parallelogram? So that we to do so we'll need the height actually. Okay, now what I do, this area of BCE can also be calculated using half base altitude. Now if I apply the same formula, half my base, this is BE, and altitude maybe I can name as ABCDEF, this is into CF, that should also be actually giving us 18√21. So now let us substitute BE as 12, thereby calculating CF. How do we calculate CF? We would simply be calculating CF as 18√21 into 2 divided by 12. That would give us some, like this is 2, this is 6 and 3, 2, 3, 6. I think that's giving 3√21. So this is 3√21 centimeters. We also, now we can use this height to find the area of the parallelogram as well. Let us now calculate the area of the parallelogram ADCE. We find area of ADCE as base into height. Now the base we can take as 13 and the height we calculated as 3√21, that's giving us 39√21. Let us add this area of the triangle with the parallelogram as well. So that's giving me 18 and 39 is 57√21 centimeters square. And also such question, you might come across a solution wherein this area used and then the CF is found, and then they directly apply the formula of the trapezium, like half and then multiplied by the sum of the two parallel sides multiplied by height. In that case also you will be getting 57√21. Hope you followed it. We take more questions in the next session. Thank you.